Today we are doing shapes. Here's some of them that you guys will see as we go through, but I wanted to show you how to figure out what they are first. So the first thing you always have to do when you're trying to figure out a shape of a molecule is draw its structural formula, like you guys know how to do. And after that, all you have to do is look at this central atom. And all you have to do is count the attachments, meaning how many things are attached to it, not how many bonds it has, not how many lines, just how many different things are attached to it. They don't even have to be different. How many total things are attached to it. So when I look at the center atom, I see carbon. How many things are attached? I have an O and I have another O. So I got two attachments. And then the other thing you have to look at is the central atom. How many lone pairs does it have? These lone pairs don't matter. It's just the ones on the central atom. So two attachments, 0 lone pairs. There's no lone pairs on the middle atom. Would make this thing linear. So there's your molecule, double bond, 2 things to the middle. And when we say bond angle, we're talking about the angle to the central atom. And a straight line, if you remember from geometry, 180 degrees across. So that's linear. If it has 2 attachments, it could be linear or it could be bent. So water is a bent molecule. But again, you look at the central atom. It's got 2 attachments, 2 things attached to it. So that is what it has in common with this one. But it also has, what's different is this one actually has lone pairs on the central atom. So if it has 2 attachments, 2 or 1, sometimes you only have 1 lone pair here. But if it has a lone pair on the central atom with 2 attachments, it's going to be bent. And there's your shape. And 3-dimensionally, what that really does, those lone pairs up there, these empty spots, actually push the bonds down this way, closer to themselves. So it looks like there's nothing here, but there really is those lone pairs floating around, pushing those bonds closer to themselves, and that's why you end up with this bent shape. On to 3 attachments, you got 2 options. You could either be trigonal planar or you could be pyramidal. 3 attachments, 1, 2, 3. 3 attachments, 1, 2, 3. The difference is that this one has 0 lone pairs on the central atom, and this one has a lone pair. So this should say, usually you end up with 1. Could be more than that, but 3 attachments, 1 lone pair would make it pyramidal. So trigonal planar, like a plane, flat. So it's a flat triangle basically. You got 3 things attached, and usually you have a double bond right there. And the bond angle, again, it's the angle right here, 120 degrees, 120, 120. Pyramidal, kind of the same thing happens that did here. Those lone pairs push the bonds down. Same thing kind of happens here, is instead of spreading out nice and even like this, that lone pair on the top kind of pushes those bonds down towards themselves, and you end up with this pyramid shape. It's kind of hard to see in the video, but if you take and put that down, it kind of stands like a pyramid. So there again, there's that empty spot. There's that lone pair pushing these bonds down towards themselves into that pyramid shape. And your angle for this one, we're kind of going to leave, the angles aren't really important. We're going to skip this one, but I did want to show you guys with these 2. Sorry, 3. And then the last thing it could be is something called tetrahedral. So the other shape you could have is called tetrahedral. Tetra means 4, hedral means angle. It's got 4 angles because it has 4 things attached. So all you got to do is look at the central. How many attachments? 1, 2, 3, 4. And then you get this shape that kind of looks like that pyramid, just with an extra thing on top of it. So 4 attachments with 0 lone pairs. Again, we're only talking lone pairs on the central atom, would make this a tetrahedral shape. So 109.5 is the bond angle for that one. So I kind of went ahead and drew these ahead of time so we could do the examples together. And all you got to do is look at what's on the central atom. So your problems you'll have to draw these first and then decide. I just drew them to save time in the video for you guys ahead of time. So you would draw this, and then you would look at how many attachments, how many lone pairs. So you draw the structural formula, you look at the central atom, how many attachments does it have? 1, 2, 3, 4. So it's got 4 attachments. And then again, we're only looking at the central atom. How many lone pairs does it have? 0. So if you remember, what had 4 attachments with 0 lone pairs? This would be a tetrahedral shape. So tetrahedral. And then go on to the next one. So we got one down here. So BCl3. Draw your structural formula like you have been. Look at the central atom. How many attachments? Remember, it doesn't have to be different, just how many things are attached. 1, 2, 3. So you have 3 attachments. How many lone pairs? Do not count these ones. You only look at the central atom. That's what determines the shape. So how many lone pairs on this boron? 0. So use your PowerPoint or the notes that you took, and you say, all right, well, 3 attachments. It could be pyramidal, it could be trigonal planar. This one has 0 lone pairs. This one has 1 lone pair. So we have 3 attachments, 0 lone pairs. So we have a trigonal planar molecule. And then one last one, NF3. So same thing we've been doing. Look at the central atom. Attachments, 1, 2, 3. 3 attachments. How many lone pairs on the central atom? Not these ones. Central atom, it's got 1 lone pair. So when you go back to our chart, either your PowerPoint or the notes you took, 3 attachments. It's this or this. So you say lone pairs. Well, this one had 1 lone pair. This one has 1 lone pair, 3 attachments. It would be a pyramidal shape. Alright, so I'll have some examples for you guys to do for homework. If you have any questions, let me know.